speaker is Mahmoud Khedher from the University of South Australia, and he's going to talk about the potential application of drinking water treatment sludge for organics removal and disinfection byproducts formation control.
Good morning, everyone. My name is Mahmoud Khedher, and I'm a PhD student at the University of South Australia. Today, I'm going to give you a quick brief overview about a part of my PhD project, which is trying to use the sludge from the treatment plant to improve the removal of organics and control the trihalomethane formation. So this presentation should be like a bit different from most of the topics in this workshop, because we are focusing more about the application more than the material itself. So if we just give a quick introduction about the problem. So as most of you know, that the climate change affecting our world, so increasing or resulting in increasing the most of the extreme events like heavy rainfall, long drought, and all this stuff. So when these events combined together in a country like Australia, which has like heavy forest and all this stuff. So for example, if we have long drought followed by extensive rainfall, this led to large flushes of organic and inorganic matter transferred from the floodplains, as you can see, into the surface water system, right? This have a significant effect or a significant impact on the surface water quality, causing rapid variation in the water quality and high natural organic matter concentrations. It is not stopped on this one, but also in the drinking water treatment, it has a significant impact on the safety of the treated water, because the residual organics also increased. So it increased the danger of the disinfection byproduct formation, which has some health issues. Some of you should have some idea about the conventional water treatment. So this figure shows the main steps of the treatment plant, which mainly has a coagulation process, in which we add the coagulant to start producing the flux, and then doing the separation process in the sedimentation and filtration before distributing to the network. During such event, when the organics loading were high, the current practice they usually do, or they usually put powdered activated carbon at the beginning and then remove it later in the separation process. This, in addition to the additional cost, also the sludge or the waste from the treatment plant increased, and they use more chemicals to improve the separation process after doing the powdered activated carbon. In addition, one major drawback of this technology of the conventional treatment is the sludge or the produced sludge from the treatment process, because it needs like additional cost or cost too much for the disposal for this one, and also it's considered as a waste to the environment. So it is very important to consider recycle or reuse this sludge in the treatment process. So in our study, we collected the drinking water treatment sludge, doing some like oven drying and burn to get rid of all the organics we have. And then we used the sieved particle, or the particles passed through the sieve size 75 micrometer, just to increase the surface area. And we use this product in our bench scale system. So this is a bench scale system. We combine the jar test, or the normal jar testing we use for the treatment in the laboratory, along with an analyzer called photometric dispersion analyzer. This used just to evaluate the flux characteristics, like the settling and growth rate and all this stuff. As you can see, this is the curve we got from the PDA. We got some factors to evaluate the growth rate and the flux size and the settling rate of the flux. So just a quick or a brief the results we found. First of all, regarding the organics, we found that we can get the same residual dissolved organic carbon or the same residual organics if we use the alum only or the coagulant only without any addition of the material. We can get it if we can save around 30% of the coagulant required using 0.75 gram per liter of this material. And also we can save up to 50% of this one, and all gives the same residual DOC. The thing which is most important for the practical point of view or for the operators is the performance of the filtration and sedimentation. And we can see from this one, from this picture, this jar shows when we use alum only, the flux was almost not, you can't see it by naked eye or from the picture, but the size of the flux increases significantly. You can see it here, and the intensity also increases significantly, and a little bit for the 3 gram per liter, but we can see the improvement on this one. Also, after the settling or after finishing all treatment processes, we can see that this without addition of the powder, you can see not all the flux settled, most of them still there, or the small ones. But when you add the powder or our sludge, you can see the water is more clear, which means that the settling improved very much for this one. And also, the sludge, when we collect the produced sludge from the jars, we can see that the volume of sludge reduced significantly by using the powder, which means that the sludge become more compact and it will improve the dewatering process and save more cost as well. The same results we have found from the BDA parameters. As you can see, this is the initial growth rate of the flux increased significantly by adding the sludge or adding the powder. And also, the flux size increased significantly when we use 1.5 gram per liter here. The second thing for the volume of the sludge produced, as we said, decreased significantly when we used 1.5 gram per liter. And the settling rate also increased significantly, which promising for the filtration performance will improve the performance of the separation process in the treatment plants. Also, when we have a look on the trihalomethane's formation potential, we can see that by increasing the sludge, it also improved or controlled the level of the trihalomethanes. So we can conclude that we can save up to like 50% of the coagulant dosing required by using up to 3 gram per liter drinking water treatment sludge. And also, we can, at the same time, keep the level of the trihalomethane safe without affecting this one. At this stage, the result shows it is promising to be studied for further research. However, we still need, in the second stage now, we are trying to collaborate with other like material people to improve the process for preparing the sludge to have more economic one, and then we will try to apply in a larger scale like a pilot plant or something like that. Thank you so much.
Questions?
Serious moment, no material, no questions.
Sorry?
No material, no questions.
Well, question for me then. Mechanistically, how does your coagulant aid work?
Mechanistically?
Yes, so how, at the molecular level, how does it work to change the floc characteristics and things like that?
Actually, it's like, it's like a nuclear condensation, so it collects more flux, so it makes it easier and heavier to be settled. So from this point of view, yeah, it will work perfectly, but still need to improve this one, like on a larger scale to have a real filter with a real sand and this stuff, so we can evaluate everything like that. But before that, because as I told you, right now we just use heat like 500 degree, which will be expensive, maybe like the powdered activated carbon or something, but we should use lower heat and use another process to produce more economic one before go to this one, just to be feasible to be used. All right?
Thank you.
Thank you so much.
Question from the audience? Okay, if not, we will move to our next speaker. And
Thank you so
let's
much.
thank for Mohammed again.